Okay, let's get started. So, today we're going to continue working on the Mandelbrot viewer. Last time we did a few different updates, such as enabling hot reloading of the shader. Now there's a few errors here still that I've noticed, but we will fix those. But let's just try some different colors. So for that, as an example, we're going to use that color. Maybe we shouldn't use a bright red. We should use something little more blue. Just directly blue. A little brighter. Yeah. $20 and maybe 0.14. It's not enough. I don't know. Something weird. So that's some weird color, but anyways. The hot reloading kind of works, but there's actually a bug that I left a note for myself here to fix. So we need to read right now. I forgot to there's a uniform that we're using to determine the screen size. And I forgot to reload that when I'm reloading the shader. Now, the reason it works right now is because program files is just doing that. I didn't remember that I was doing that in program files. And it's also doing some other stuff, which we'll go look at right now. Oops, wrong type, wrong thing. So before that, I need to made some changes to this, and I be testing those while I'm doing this. So well, I'll just leave those for now. It's fine. You can probably do it on a different screen. You just okay. So let's restart this. Let's look at program from shader files. So program from files. So actually, let's look at the main loop first to see what the issue is. So in the main loop, when we reload the shader, we are expecting this program from files to just return the new PID. And if the new PID is greater than 0, so it was a successful, we successfully got a new shader, we go ahead and delete the old program, set the PID for the new program, and then we use the new program. We should also be checking the uniform here, which we're not, but well, so program from shader files, it creates a new PID, and it attaches the shaders for the new PID, and it links the program, and then right, why did I think this was, definitely didn't fix this before. Why did I think this was doing the wrong thing? It's not doing the wrong thing. I'm just dumb. Anyways, we should still be checking this either here or in the main loop. Now one thing about this is that we can actually we can delete some of this code here, so we don't have so much duplicated code. I don't know. Neither here or there about that. So first of all, these can just get initialized to 0, and then yeah, it's just less code, so we'll just do it this way, even though this could just crash and be an issue, but that's fine. So if we start these out at 0, we do our comparison here, it's gonna come out as like true, and then we go ahead and make our new program file. We get our new PID, and we should update this uniform. Kind of prefer to just do this in the loop with the rest of the code. And also this screen dimension needs to be set in a different place. Am I getting emails? No, nothing important. Yeah, so you know what, that's okay. We will still set this, let me take this out, program from shader files, we're gonna, oh right, that's the problem. So yeah, so sorry, right. The problem is that we're using this new PID, we're not actually, after we've gone ahead and done this link and all this, we're just immediately starting to use this program. We don't want to do this, we want to delete the old shader first, and then use this program. So that line shouldn't be there. That's what the problem is. Now, because then we go ahead and like delete some other stuff and switch a bunch of stuff around. We don't want to do that. So that's like the one problem. This I will. Yeah, this needs to be moved because basically this applies only to the current PID. So this needs to be, we need to make sure that shader is valid first before we go ahead and do this. So we will do this in this loop here as well. So if this is successful, we will, update this uniform, set this variable, or set this uniform in the GPU. Let's move some of this around. Let's just do this. I32 USD for my American friends. And then make sure this is all looking good. Okay. So if USD, well, this is equal to USD, USD does not equal 1, USD, it's a bit better. Also, we can't do this yet because we're not using the new program, so we have to do this first. So this is the correct order for this to be occurring in. Delete the old program, set the new program, use the new program, get a uniform of the new program, and that is that. So, yeah, so that should be good. Now this should just get initialized so we can restart this, do a rebuild. Oops, that was silly. Highlighted that code and removed all the capitals. My bad. Okay, so now if we go back to the Mandelbrot, so GL error high, invalid operation, GL uniform program not linked. How is that happening? Oh, because we're resizing the window before the program is linked. Good. And also because yeah. So actually what we need to do before we even start any of this is we need to set that uniform to 0 or to -1. So, oops, there we go. No more error about that because that bug is now corrected. So, how is this all going? This all looks good now. Still like on the fence about doing this check first because we need the program before we just think we'll leave this part of the code alone, to be honest. Sweet, oops. Want that still for the default behavior. And then this behavior we're gonna delete. I still like to exit if we can't load the initial program. For whatever reason. So that, and then what am I trying to type here? Didn't desync. I keep that enabled so we're not completely blasting the GPU for no, or blasting my computer for no reason while I'm streaming. So me, what do I say? Actually, there's still a bug here, so yeah. So by removing that, I haven't set the. I need to use the program. Okay. Oops. Um. Duh. Okay. Uh. silly man. So, this code needs to get run at the start as well before we start anything. So, should remember how my program works, but anyways, so technically, that's fine. So, okay, yeah. Okay, back up and running. How we want. So let's commit this so we have something to work off of. Um, so fix God, sometimes commit messages are really annoying. Make sure the program is valid, or make sure the program ID gets updated properly in technically that other code should have still been working, but I don't know. So we will just, yeah, I'm not gonna think too hard about that one for now. Oops. So let's go back to our shader. Now there was a crash before, and I tested this elsewhere, and it wasn't crashing, so I'm not really too sure what the problem was. That worked fine. This should also work fine. Huh. I'm not really sure why that crashes the program, to be honest, and I don't even think it will launch if you have it like that. Yeah, I don't know what the problem is there. Yeah, that's really weird. Graphics driver issue probably, but for the time being, we will just not mess with that too much because it's not that important. Um, so what we want to do is finally get some better colors going on here. Actually first, you notice that this is like always stretched, so I should correct that. I don't like it. It doesn't need to be like perfectly filling the window every time, though it could. Um, but really, I think I'd like this to keep the proper aspect ratio. So um, should leave some like comments in here because we can modify this. So X um, is in what's it called? minus 0.47 to sorry. What? What was v dot x here again? We passed the fragment shader divided by the screen dimensions. So right now x starts out at 0 to 1. And then we multiply it by 2.47. So then it's going to range from minus 2 to 0.47. And then y is in minus 1.12 to 1.12. But we want the screen aspect ratio to remain. Let's do this. We want the screen aspect ratio of this to match the Windows aspect ratio. So let us class a float aspect. Whatever. It's going to be equal to the screen dimension dot x over the screen dimension dot y. Oops. Thing live again, or did I kill it? Should still be live, yeah. It's okay, so so with this aspect ratio, what we want to do is say we want to basically make sure that x to y is equal to this. So to do that, we say that x over y should be equal to aspect. So basically y times aspect should be equal to x. I think that would always just work. So, but such that it contains these values. I think we can let's just try this y. No, that won't work. This is just like a dumb linear mapping thing, and I'm having a dumb. Basically, we just want to like recompute the bounds of whichever one of these. So if the aspect ratio is greater than 0, meaning that x is wider than, meaning the window is wider than it is tall, we want to extend x. And actually, we might want to add like some padding to y as well. So like maybe this should have already just been like 2 point. Whoa. Oops. Should have been like 0.6, right? So yeah, it's like not enough. We need to like add some extra padding. But So if aspect less than 1, else so we want x to be, it needs to contain this range, but it can also contain some padding. So I think I should like extend this range a little bit to maybe minus 2.5 to 1 as like a minimum. So that means we have to multiply by 3.5 and subtract 2.5. That's going to contain that area nicely. It's still not quite what we want, but so we want the aspect ratio to be correct. So our x range here is now, we want to actually do this before we just shift the stuff around. So right, so why am I like having problems with my math today? So the original midpoint, we need to keep the original midpoint from moving, basically. So midpoint is isn't like even, so it's like really annoying, but I can use my friend the old EC. So original midpoint was 0.47 minus 1.235. So original midpoint was minus 0.765 and 0. So we want the midpoint of our whatever our new range is to be this still to keep things centered. And then to do the aspect ratio. So yeah, we have some target X and Y range that we want. Maybe minus 2 point. So yeah, what I had before was good. What did I do? Minus 2.5 to 1. So (2.5 to 1). Which basically equates to a range of 3.5. It should be there. And then for y, we want to go from like, I don't know, maybe 1.5 to 1.5. So well, again, I'm typing some invalid code again. Yeah, well, that's not going to work, but basically there's some padding now, which I think is good. So y new should be 1.5 to 1.5, and then so that means it has a 3. It has a range of 3, which means what? It means that we have a new aspect ratio that is 3.5 over 3, and we need to scale one of these. So if the screen is wider than it is tall, we need to scale x. So x scale is equal to yeah. I'll figure out how to do this properly in a second here. Desired aspect is equal to 3.5 over 3. Good. Bad, dumb. So okay, so desired aspect is going to be, x is going to be equal to uh, so 3.5 brain, help me brain. Math is hard. So 3.5 over 3 is the desired aspect ratio. The current aspect ratio is less than 1, which means that, so this is actually the wrong case. In this case, we should be setting the y scale. If the current aspect ratio is greater than 1, then that means that x should be wider than y, which means that that the x scale, so if y is now assumed to be 1, then the x should be so sorry, this is the x scale. So x scale is 3.5. So yeah, it's just desired aspect. and 1 over desired aspect. That's not valid code. Okay, so then what we do is we can say that, well, we don't need this extra bit of code here. Yeah, we just need to do this correctly, basically. So x is going to be equal to b dot x times 3.5 times desired aspect ratio, and then x minus equals, so we're gonna have our new thing here, which is now going from 0 to 3.5 times desired aspect ratio. So our delta is gonna be our delta is going to be 3.5 times desired aspect ratio minus 0.75, right? What did I do here? Yeah, good. That's not quite centered how I would like it to be centered. So, this is not right. Yeah, duh. So, we want delta to be equal to 3.5 times desired aspect ratio plus x equals this. So x equals well, also it's the midpoint of this. It's not exactly this, right? Over 2 plus x to be equal to that. So this, so minus 0.765 plus over 2 should be the right thing. No, because I'm dumb. Plus, minus. Okay. Good, good, good. I do know how to do math. I only have a degree in engineering. It's fine. Oh god. Happening. Um, but x isn't always being set in this case. So what we need to do here is well, yeah, this has like a different value. It should be initialized too, but let's just start by doing this properly. I think it's always delta x as well. I don't think it's ever delta y because y is just going to be centered, but that's fine. So delta dot x will equal this. Do that. Do that. Y is always just going to be centered, so that's fine. Um, it should just always be minus 3 over desired aspect ratio over 2. And it's always what y is going to be, no matter what. That's not centered. Those variables are done. Why is that not centered? What happened there? Oh, because we're not accounting for like the actual aspect ratio. Right, so what's the actual aspect ratio? So we have a desired aspect ratio, we have an actual aspect ratio. We need to remap. Need to remap this guy, so it needs to be scaled by the actual aspect ratio. If I'm not mistaken. Because the actual aspect ratio oh right, we're doing this check. Y still needs to be scaled no matter what. Same with X. I think what should happen here is that so where did I forget to put a semicolon? It's a good question. Am I just, you can't do this maybe? I don't know. What did I do? Am I blind? I don't know what I just did. Yeah, I'm just dumb. So, okay. Not this anymore. So vec dot y equals this one, and vec dot x times equals that one. I'm still having some syntax error. Yeah, good. OpenGL errors are. I'm still having a syntax error. What is going on? Maybe these are not allowed. I thought they were, but. What is the syntax error here? Hello? An XY error somewhere here? Am I like blind? What on earth did I do? Try this again, shall we? Okay. I don't know what I just did. That was strange. So, what is going on? Why am I doing something completely wrong? Y needs to be shifted down. Why? This doesn't come into it. It just comes. It goes with X. What is going on with my math today? And this. What is this? I don't know. I don't know what's wrong with my brain today. We will just stop this nonsense for now, I think, and um, let us just leave this code. I'll come back to this code a different day. Um, oh God, what have I done? What is this code? Well, yeah. Okay. uh, too tired on a Friday. Jeez. So that is fine and dandy. Now let us leave that as is for now, and I will figure this out later. Um, when my brain is working properly. For now, let's start by doing these colors. So there's a few different ways to do the colors. Let me just find my note thing here about doing the colors. So basically for the colors, what we have here is we have some integer count and we want to somehow map that to like a color space that's related to, either the visual spectrum or whatever. Um, so I think to start with, we're just going to try to do something with like HS V. So let us say that the escape value here is the actual hue value. If the Yeah, so if we're less than this, as long as it is in the set, let us define a new vector here. Vec HSV. This is going to be 0, 0, 0 to begin with. Now, if it's less than this, we are going to set vec3 dot x, which will be the h value, to I. It's actually not going to be 0, 0, 0. It's going to be 0, 0. Let's just say the saturation is 255 and the value is 0. Not vec3. HSV dot x is equal to I. Now, HSV dot the z is going to be equal to the value in this case will be 255. And then to get our color, which does not need to be set up here, set down here. Well, to be set somewhere. So let's just set it up here for now. To get our color, we need to convert from HSV to RGB. So there's just like a matrix we can use, HSV to RGB. There will just be like a coefficient. I just want the matrix. There's like a 3x3 matrix that will just convert to. Where is the 3x3 matrix, please? Um, what on earth? What is the conversion? I thought there was just like an easy, simple conversion. So first of all, make sure these are all normalized to 1, not 250, whatever. Um, and then I don't want to write this as a function because I'm pretty sure there should just be a matrix for doing this. Maybe I'm wrong, but for now we will just write HSV to RGB. It's not going to be void. It's going to return a vec3 HSV to RGB. So it will take a vec3 HSV, and then it will compute a few values here. So it will compute Cmax, which is equal to the, I don't know if this is a function yet. I can't remember if this is a function in GLSL. We will find out. C min, otherwise I will have to write it myself, will just be the minimum. Delta will be C max minus C min. And then you kind of need to know which value is which is really annoying. So also this is like from, this isn't the right equation anyways, this is the wrong way. About HSV to RGB. There is just like supposed to be a table. Oh, so okay, so apparently maybe HSV is not like a matrix. There is like a different value that's a matrix. So I'll probably use that one instead, which I think is HSL possibly. Let me just go to Um, okay, so for this one, let's do this properly. So we need what on earth is going on? So this is like a bit of a convoluted mess to do this. Maybe HSV is not such a fine color space to use for this, but um, so on Wikipedia, there's some equations that I will just follow here. So 1 minus 2, 2, 2 times the value, so HSV dot Z minus 1. I don't know why they wrote it like this, but they did. And then this whole thing should be times by the saturation, which is HSV dot Y. Then they have H prime, which is the H value, but from 0 to 6. Which is a little weird because it doesn't have to necessarily be not this, I want round. Then they have equal to C times 1 minus H mod. I don't know if that is an operation in GLSL. Modulus GLSL. Don't know if you can even do this operation. I think you can. There's mod. Okay. Yeah, so you can use the mod function. So mod H and 2 minus 1 and then is equal to HS V dot z minus c over 2, then vec3. So what a complicated mess. I don't really want to write this code, but I'm going to write it anyways and see if it is just awful. So if h is less than, no wait. Yeah, so if h less than 1, else if h is less than 2, don't even ask. But so we would probably use a different color space that's a bit better behaved. Vec 3 RGB equals vec 3 0. Okay, so RGB equals vec, I guess in all these cases initialize, so let's delete this. Vec 3 CX0 else that's not gonna look nice. Never mind. So else this is just wild, very wild formula. Don't even ask. 0C X 0XC. Kind of like I'm counting in binary, but the numbers are, the binary digits are all weird. X0 C and then C0X. And then RGB plus equals vec3 of M. And we're going to return. Okay, so we're going to actually just return RGB plus vec3. H use uninitialized. Hello. Yeah, that needs to be an X. Okay. The H will not be used uninitialized now. And then delete all this. And we can say that just me. Well, that is definitely not the color we wanted. Nice. Very cool color. My eyes. What happened here? So what happened with this? Why is this always giving some gigantic value, basically? Basically, the problem is that this is not being somehow we have ended up with a value that is not correct. So I think we should find a better color space, to be honest, or better pattern for figuring out the colors. I think so there's like a lot of there's some ugly complicated formulas that I don't really care about. Um, Now on the other hand, yeah, maybe we'll just do that. So one thing that we could technically do is not do this for now. I'll come up with this later. Um, we can actually treat this as like a wavelength. So um, if we set this to 300 iterations, which is too many, but we just do that. I've deleted that because I need some code here. That's fine. So if we set this to 300 iterations, and then we write a function called vectory wavelength to RGB. And this is going to take a float lambda. And there's actually like some other ways of doing this, but well, I don't want to use that. We're going to use this equation that is a bit annoying, but well, this equation is like horribly ugly. Awful. Absolutely awful. Well, it is what it is. There's a yeah, so this is gonna be some ugly, ugly, ugly. But we will do it anyways. Um, this is gonna be some absolutely beautiful code that I'm gonna be so proud of writing. I'm definitely not being facetious. um, okay. 410, 475. For some reason, there is some weird. Yeah, nice. So we this is for comment this. This is for reds. And then there will be one for greens. So the first one for reds. What a fantastic function. What a fantastic piece of code that we are writing here. Um, Now don't ask me why there's like a discontinuity in the middle of this, but there is, so we'll just deal with it. So P is equal to lambda minus 400 over 10 RGB.x is equal to 0.33 times t minus 0.2 times t squared. In this case, this is an amazing, just masterpiece. People can only hope of writing this beautiful piece of code themselves one day. Oops. Uh, well, I think we'll just stop that to stop that from spamming us for a second here. What I can do actually is comment this out. Wavelength to RGB I1. Let's see how this is gonna not work. My bad. Yeah, that's fine. Oh, right. So this should be these may need to all be wrapped like this, which is very annoying. But these ones have any other code yet, so lambda undeclared. Why is lambda undeclared? Oh, Jesus. I should just use L for this case, but whatever. Okay. So we are back to something reasonable. It is very red right now, but that's okay. It's better than nothing showing because of stupid typos. Let me just verify that this was needed. I don't know if it was. No. So I will remove that because I don't think that is necessary. It's kind of ugly. Okay, let's go back to our nonsense values. Um, Man, this is some ugly piece of work code. Let me tell you. Yeah, and no matter how I write that, it's gonna be ugly. 50. Um, should not be there. So showing up, yeah, it still shows up on screen. So we're getting somewhere here. Slowly, but this is something. Um, I don't know if this is the best color spectrum to just use, but now it'll be okay. Um, code is very hard to read that I am following here. This, I guess I'm not following code, but so that one is good, and then the next one is going to be this one. We are going to do 0.98 plus 0.06 times t minus 0.40 space times t. Why did this not line up? Then in the final case for the red, we will do probably we want this to not be colored inside anymore. So this one is 0.84, and it's minus, and then this is plus. Okay. So there's the reds. Now, copy this awful code, but for green. There's less cases for green and blue, which is nice because obviously they're higher either shorter wavelength, higher frequency, so there's only a couple cases for each of them. So if green starts out between 415 and 475, do our same weird thing here. And then this is Y. So Y is, first one is all of this is blank. And then this is plus 0.8 t squared. Add some green there. I don't know what this looks like on this stream. It looks probably fine. It's hard for me to tell because I've got like a fairly high quality monitor, so I don't know what shows up on the stream and what doesn't show up on the stream. So this should. So 0.8, and then what else do we got here? Okay, the next line is green between 475 and 590. So then we have to delete 475. And 590 minus 475 is 115, right? 0.15 and 0.8, and then plus 0.76 times t. Oops. Okay. I need to not do that. So it should be like that. 0.76 times t minus 0.8 t squared. Is that right? Okay, that is, yeah, it should be like that. Why is this not aligned? Oh, yeah. And then finally for the green, it will be between 585. Weird. Good question. Don't know why that's like that, but it is. I am gonna fix that. 'Cause that makes no sense. 585 and 639. Which I cannot do that one in my head right now. 639 minus 585. 54. And in that case, we are going to do 84 minus 84t, and the rest of this is gone. Okay, then finally the blue, and the blue is the shortest, so delete all that junk. So blue is the shortest, it only has like 2 cases here, so let's delete that. If lambda is between 400 and 475, oops, then Z gonna go to here, and we are gonna do 2.2 times t plus minus 1.5 times t squared. And then finally, blue between 475 and 560. That is going to be 60 plus 25 is 85. And then this is going to be 0.7 minus E plus 0.3. Cool. So that is what we are getting now with our 300 iterations. I'm not actually even sure if we need to do this. That's fun. Yeah, I think we'll keep that nice weird color gradient. Why not? Where am I here? So that is gonna be good for now, I think. So what time? How long have I been streaming? I think it's been a couple hours. Not quite an hour and 40 minutes. So let me see here if there's anything weird that I should be cleaning up. Technically, you can actually make this value bigger. And it shouldn't really change anything, but yeah, it's a bit better. It'll just fill out the screen a bit more. Okay. Um, so yeah, for now, I think that is looking pretty good. Um, the next step that we want to just take is to get rid of this weird gradient thing. So because we're using like these discrete steps of integer, actually I can probably do this one actually really fast. So maybe we'll just do that quickly before I'm done. So this thing that people talk about called renormalizing the Mandelbrot set, or specifically renormalizing the escape part. So this integer is consisting of discrete steps, but we want this color value to be smooth. It shouldn't be like there shouldn't be discrete steps between different colors. So basically, if um, if we want to do that, what we have to do is calculate this value called what they call mu. And I don't know if I want to talk about the math behind this stupid value right now, but um, let us do it. So first things first, let's just compute mu is equal to float basically equal to I minus log the square root of x squared plus y squared. Don't ask why right now. I mean, yeah, and then divide by log 2 because the equation actually considers it to be in what's it called, base 10, but this log is base 2. Good, and then mu so if mu is greater than 300, mu equals 300. We should probably like fix some of this later. If mu is less than 0, mu equals 0. The reason we're getting, actually I don't know why we're getting that weird gradient, but regardless. So there, that is looking a little better already. So we've got rid of a lot of that banding that was just going on, just by using this sort of trick to get rid of this comment, to convert this integer I into a smooth value. So Now this mu is smoothly ranging between 0 and 300, which basically means that we can get like a nice smooth gradient, which so far is looking pretty good. But there's some other things here that could still be corrected, I think. I'm not really sure. I think I might have RGB should be correct. So I don't think I'm missing any other parts here. So far, I think this is looking pretty good. Don't think you really need to cast this. Shouldn't change anything by casting this. I don't know why they didn't. Why the example I'm looking at did this. Yeah, I don't think that does anything because it should just automatically be. It should be auto cast. Um. Good. So there is like another thing we can do to renormalize like the gamma so it's not like so bright like this, but um well, sure. Let's do that. Uh is equal to the power of um so it's just like a normal gamma renormalization, so mu over 300 times 0.2 and then 300 times mu. I need a semicolon. Well, that is not quite right, is it? Not times mu, times q. There we go. Um, but that is a little annoying. So this might like look better if we're actually zooming in, and also I feel like the color's like weirdly inverted for some reason. Um, why would that be? I think we're gonna delete that part for now and just do the uh, just leave it at that, which looks pretty nice for now. Um, so yeah, so far that's looking pretty good. We still need to do like the zooming, so that would be for next time. So thank you everyone for watching again. I will commit and push this to the GitHub, so if anyone is following that, they can close it or they can clone it. I don't think that I can post that link on YouTube. I don't know. Anyways, it's on my GitHub. You can find it if you want to try this out. So right now it only works on Linux, but maybe next time I can add some of the Windows code, possibly if I feel like it. But for the time being, this all is looking pretty good. So, yeah, I'll probably stream again tomorrow. So thank you for watching. Bye for now.